Welcome to Maths with EJD. In this video, I continue with generating functions, and here we are beginning to look at generating functions in probability. In the previous video, we had looked at generating function in combinatorics, and we saw, ideas like Catalan numbers and things like that. But here, we are going to be focusing on how generating functions appear in probability. And that's why in this particular video, our focus is on introduction to probability generating functions. Okay. So first of all, it is important to know that generating functions are powerful tools in probability theory that provide a way to encode sequences of numbers such as probabilities or moments into functions. So they provide a way to encode sequences of numbers such as probabilities or moments into functions. Okay. They are particularly useful They're particularly useful for solving recurrence relations, analyzing sums of random variables, and handling distributions. Okay, so having said that, let's look at uh, something more usable as far as this is concerned. Okay, all right. So again, the probability generating function. So our focus now is on some mathematics side of this. The probability generating function, PGF. We have generating function now. The focus is on probability generating function. So the probability generating function, that is PGF for short, of a discrete random variable. Discrete random variable. So it applies to discrete random variable X with a probability mass function. Interestingly, I have a whole playlist on probability. You can check that out so that in case you need to know other aspects of probability. So the probability generating function, PGF of a discrete random variable X with a probability mass function, Okay, let me separate that. The probability mass function P of X equals X is equal to P small piece of X is given by, is given by, so we're talking about the probability generating function, and that is G sub X of small s is equal to the expected value of small s raised to power X. And that is equal to the summation from X equals 0 to infinity of the product of the probability and s raised to power X. So that's how that goes. So this is a very important expression to pay attention to. So that's the probability generating function. Okay, so those are the basic definitions now. So the probability generation function PGF of a discrete random variable x with a probability mass function. This is given by this. Okay, now let's take an example to drive home the point. Imagine this. Imagine this example. Let x let x be a discrete random variable, with the following, with the following probability mass function, PMF, probability mass function. We have probability density function and probability mass function. With the following probability mass function, PMF for short. So, and that probability mass function is actually P of x equals 0 is equal to 0.2. So probability that x is equal to 0 is 0.2. Probability that x is equal to 1 is 0.5. And probability that x is equal to 2 is 0.3. And that, of course, follows the law of probability. If you add up all the three probabilities, your answer is 1. Because probability, the highest value of a probability is 1 and the lowest is 0. So if you add up, if you add up 0.2 plus 0.5, that's 0.7 plus 0.3, that's 1. So that follows what a probability should look like. All right. So the question is, let x, okay, we have this, let x be a discrete random variable with the following probability mass function, this. So if we have this now, and we need to compute the PGF, compute the probability generating function. That's the kind of question we have in that situation. So for the solution, see what we have. We already know from this definition, right, that the probability generating function is actually this, is the summation of all the probabilities multiplied by s raised to power x. Okay, so see what that looks like now. We have g x of, okay, first we can write down the PMF, right? We can write down the PMF. We know the PMF is P of x equals 0 is 0.2, P of x equals 1 is 0.5, and P of x equals 2 is 0.3. Then from what we learned already, we know that the probability generating function the probability generating function is gx of s as gx of s, and that is equal to the expected value of small s of x, which is the same thing as summation from x equals 0 to infinity of probability x s raised to power x. Okay, so in this case, we just have it, we have it in three situations. We have it in three cases. So having taken care of this, it means that we're going to have like probability starting from 0, right? So we have P0, S0 plus P1, S1 plus P2, S2. Okay. I think that's all we have, right? It only goes as far as we have just three terms. So that's as far as that goes. So, this is what we mean by this is our P1, this is our P2, and this is our P3. Okay, this is P3. So we can just fix all of that up. So P0 is 0.2, S raised to power 0 plus P1 is 0.5. That's probability. That's 0.5 s raised to power 1 plus P2 is 0.3. Okay, so this is P1, this is P2, this is P3. P3 is 0.3, so we have 0.3 s squared. And then that is anything raised by 0 is 1. So this is just 0.2 plus 0.5s plus 0.3s squared. And this is the probability generating function. Okay, so we can just conclude and say, therefore, the PGF, the PGF for the given probability mass function is gx of s, and that is 0.2 plus 0.5s plus 0.3s squared. So that is what that is, basically. All right, so in the next video, we'll be talking about moment calculation from probability generating function. So so you don't want to miss out on that. So subscribe to the channel, hit the notification bell so you don't miss out on short videos and other videos that will come after that. Comment, let me know how helpful this video is, and let me know if there's a problem to solve or a topic to teach. Then like and share so that more people can have access to this great content. Bye.